What would you say if I told you that someone had invented a widget that could harness the power of big institutions, big governments, and big corporations and miniaturize that power in such a way that it could be accessed easily by the masses from a handheld device? How much would you be willing to pay for that widget? Would it surprise you to learn that it's completely free and that you're probably using it right now? What am I talking about? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
In today's tutorial, we're going to learn about an amazing invention called SQLite. You'll learn about its history, its inventor, and its uses. We'll use it to learn about databases in general, and then we'll learn where SQLite fits in. Finally, we'll learn how to use the SQLite.jl package, which is a Julia wrapper for SQLite. We'll use the SQLite.jl package to work on a couple of Julia projects. For this tutorial, knowledge of Julia and VS Code is required. Okay, let's get started. Before we get started, let's get the elephant out of the room. How do you pronounce this? The inventor pronounces it SQLite, but he has also stated that he doesn't care how other people say it. Other variations include SQLite, SQLite, or SQLite. That last one is the easiest for me to say, so I'll be using SQLite in this video. SQLite was invented by D. Richard Hipp in the year 2000. After receiving his PhD in computer science from Duke University, Richard Hipp started his own software consulting firm. On one of his consulting engagements, he needed a program to access a database, but he didn't want to install a huge database management system that would require a dedicated database administrator, which was the standard practice at the time. Since nothing like that existed in the year 2000, he wrote his own code to solve this problem, and he made his code available to the public. And thus, SQLite was born. According to Wikipedia, SQLite is a relational database management system contained in a C library. So, what does that even mean? Before you can comprehend just how amazing that statement is, we need to go back in time to learn about the history of databases. Databases have been around since the dawn of computing, when early computers would store data sequentially onto magnetic tape that could be retrieved and/or modified by a user at some point in the future. This was accomplished by pointing to a specified memory storage location where that data was stored. In 1969, while working at IBM's San Jose Research Laboratory, computer scientist Edgar F. Codd proposed a wildly different concept of data management, where all data is represented in terms of tuples grouped into relations. He envisioned that applications could search for data by content rather than following links to memory locations. A database organized following this relational model would come to be known as a relational database. When Edgar Codd came up with this theoretical relational database model, computers were not powerful enough to implement his vision. That changed in the 1970s. Silicon Valley entrepreneurs Larry Ellison, Bob Miner, and Ed Oates were inspired by Edgar Codd's theory, which had been published as a research paper available to the public. In 1977, Ellison, Miner, and Oates decided to start a company to pursue Codd's theory, and their company would eventually be known as Oracle Corporation. Initially, their company specialized in relational database systems for large enterprises in both the public and private sectors. The company grew rapidly in the 1980s as governments, corporations, and institutions invested heavily in new computer technologies that were built using Oracle databases. Today, Oracle is one of the largest companies in the world, and Ellison is one of the richest people in the world. Part of what fueled the successful adoption of relational databases was the language that was used to manage that data. That language was created in 1974 by Donald D. Chamberlain and Raymond F. Boyce, who were colleagues of Edgar Cott at IBM's San Jose Research Lab. Their language was initially called SQL, which stood for Structured English Query Language. The name was later changed to SQL due to a trademark conflict, but even today, there's still debate whether the proper pronunciation of the language is SQL or SQL. The breakthrough concepts behind SQL was that it allowed the user to access many records with a single command, and that it eliminated the need to specify how to reach those records. In other words, the people who needed that information for their job could now obtain it without needing to be a computer programmer. All of this history leads to the year 2000, when Richard Hipp invented SQLite. At the time that he wrote his code, he didn't realize the impact that SQLite would have on the computer world. He wrote it to solve a very specific problem that he needed to solve for his consulting engagement. It didn't occur to him that there might be wider uses for his code. As it turns out, the time around the year 2000 was a transitional point in the history of the Internet. Tim Berners-Lee invented the World Wide Web in 1989, and the Internet experienced explosive growth during the 1990s as consumers flocked online. While consumers were plugging into the World Wide Web, electronic devices were also starting to connect to the Internet as well. By the late 1990s, the term Internet of Things came into vogue as the computer world envisioned a future where electronic devices would someday outnumber human beings on the Internet. But before these so-called smart devices could take off, several new technologies needed to be developed. One of those missing pieces was a compact database that would be small enough to fit onto a portable device. Developers of these smart devices recognized the potential of SQLite, since it allowed them the ability to offer the power of a complete relational database on a portable device. Not long after its invention, SQLite started being installed onto devices that were connected to the Internet. In 2007, Apple introduced the iPhone. The network hardware company Cisco Systems estimates that sometime between the year 2008 and 2009, the number of devices connected to the Internet overtook the number of people on the Internet, and thus turning the Internet of Things into a reality. Unbeknownst to most people, one of the secret inventions that made this growth possible was the invention of SQLite. According to the SQLite website, SQLite is an in-process library that implements a self-contained, serverless, zero-configuration, transactional SQL database engine. That means that it doesn't require any extra hardware, so naturally, it doesn't require a database administrator to configure it or maintain it. The data is attached to the application and thus is attached to the user of that application. SQLite is small, lightweight, and portable, and can function in any operating system. It's in the public domain, so it's free for anyone to use for any purpose. Sound too good to be true? Well, SQLite is very honest about what it is and what it isn't. SQLite is not a replacement for the traditional relational database management system. SQLite has a completely different purpose in life. If you're working in a large, highly centralized enterprise, then a traditional relational database management system might still be right for you. But for everyone else, SQLite is the database engine for you. Today, SQLite can be found in smartphones, television set-top cable boxes, automotive multimedia systems, and countless other devices. According to the SQLite website, SQLite is likely used more than all database engines combined, with billions of copies existing in the wild. That's billions with a B. In addition to smart devices, it's also used in most web browsers and many commercial software applications. Like I said in the intro, you're probably interacting with a SQLite database at this very moment, and you don't even realize it. I know that's a lot to take in, and history lessons can be boring. So let's jump into VS Code and see SQLite in action. In this exercise, we're going to learn the following syntax using SQLite.jl. 1. How to create a new SQLite database file from Julia. 2. How to execute SQLite commands from Julia. 3. How to add a table to your SQLite database from Julia. And 4. How to add data to your table from Julia. Let's start by opening VS Code. In the Explorer panel, create a new folder for this tutorial. In the tutorial folder, create a new file called add_contacts.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Maximize the terminal panel. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Add the SQLite.jl package. Type in status to confirm the version number. Exit the package REPL by hitting backspace. Minimize the terminal panel. Before we get to the code, we need to add a VS Code extension for SQLite. In the Extensions panel, search for SQLite and install the SQLite extension. This extension will allow us to view our SQLite database from VS Code. Okay, let's learn some basic SQLite syntax. In order to create a new SQLite database file, use the SQLite.db constructor. When creating a new SQLite database file, you have three different options for the file extension. You can use .SQLite, .SQLite3, or .db. I'm going with .db. Also, when using the SQLite.db constructor, it will check to see if that file already exists. If it doesn't exist, then it will create a new file. If it does exist, then it will just load the contents of that database and assign it to your variable. If you look in the Explorer panel, you should see a new file called contactdata.db. Once you create a new database, you need to add a table. A database is just a collection of tables, so you can add as many tables as you like. For this exercise, we're just going to add one table to hold a list of contact information. The SQLite.execute function allows you to execute SQLite commands from Julia. The first argument is the variable name for your database, and the second argument contains the actual SQLite code inside the quotation marks. Create table if not exist does exactly what it says. It will check to see if your database already has a table with a name that immediately follows this command. If the table does not exist, then it will create a new table. If the table does exist, then it will do nothing. The convention when using SQLite is to enter SQLite commands in uppercase, and to enter your database-specific code in lowercase. This is not a requirement. This is just a style guide convention, and considered good practice when using SQLite. The table headers are placed within the parentheses, with the column names in lowercase, followed by the data type in uppercase. The columns are separated by commas. By using the command primary key in the ID column, SQLite will know to automatically increment the ID number every time you add a new row of data. In order to add rows of data into your table, you use the SQLite.execute function again, except instead of using the create table command, you use the insert into command. As you can see, when adding strings to your database, use single quotes. Now you can copy and paste this code to add more rows of data. Okay, so that's the basics of setting up a new database in SQLite from Julia. So now you're probably wondering, how can I view my data? If you click on the contactdata.db file, nothing is displayed in VS Code. Unlike a .txt file or a .csv file, the .db file is not a text file. It's a self-contained relational database file, meaning that it's like a little magic pocket universe. In order to take a look inside it, we can use the SQLite extension. Go to View, Command Palette, and search for SQLite. Select SQLite Open Database, and then select the contactdata.db file. You should see a new panel appear at the bottom of your Explorer panel that shows the name of your database. If you expand the database, then you'll see your table called Contacts. If you expand the table, then you'll see the column headers along with the data types. Next to the table name, you should see an arrow. If you click on that arrow, the data inside your table should appear in a new panel. Pretty simple, right? This extension gives you some options if you would like to export your data in a different file format. You can export it as a CSV file, an HTML file, or a JSON file. Also, you don't have to worry about saving your database file. Every time you enter a command in SQLite, it automatically saves your database file. But you do have to save your .jl file, so save your file and close all the open panels. Close out of your Julia session by hitting Ctrl-D. Now that we know the basics, let's try creating a simple app using SQLite.jl. This project is based on the code for the simple text-based app that we created in the very first episode of this series. Our app will ask the user to enter in some text, and then the app will reply with something innocuous. The app will remain in an infinite loop until the user decides to break out of it. And that's it. Let's get right to the code. Launch the Julia REPL by using Alt-J, then Alt-O. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Exit the package REPL by hitting backspace. In your tutorial directory, create a new file called sourcecode.jl. Just as a reminder, this command line code will allow us to clear the console window programmatically. Next, let's add the code to create a new database. Next, let's add the code to add a new table to the database. Now, we need to define a function that will launch our app. So, this is our app function. The only thing that's different from episode 401 is the line containing the SQLite command. Now, save your file and try running your code. Maximize the REPL panel and call the memo app function. Okay, so what just happened? The app never asked you if you wanted to save anything. So let's take a look inside the database to see if there's any data there. If you open the user underscore entry table, you should see everything that you typed in. Now, close out of this Julia session and start a new one. Rerun your sourcecode.jl file. Maximize your terminal panel and call the memo app function again. Now, hit the arrow for the user underscore entry table and take a look. All 6 of your entries should now be showing. Seeing your app in action should be both amazing and unsettling at the same time. By learning how to use SQLite.jl, you now have the ability to save data locally from your Julia app, and there's no need for you to invest in some fancy database software or hardware. That's the good news. But here's a cautionary note. This app that we created is saving user data onto their hard drive without asking for permission, either from the user or from their operating system. This means that you now have the ability to track user activity without their knowledge. Your web browser is doing this by saving your browsing history and related cookies, probably on a SQLite database saved somewhere on your hard drive. This, of course, raises a number of ethical concerns. An app using SQLite can track just about anything a user does on that device without their knowledge. This was one of the big aha moments for smart device developers. Although SQLite was originally created just to be a self-contained relational database, developers have discovered that they can use it for other, novel purposes, since SQLite has the ability to bypass an operating system's file management protocol. Now that you know what SQLite is, you know what to look out for. I am not the morality police, so I'm not here to tell you what to do or what not to do. All I'm going to say is that just because you can do something doesn't mean you should. Well, that's all for today. If you made it this far, congratulations! Today, we got a lesson on the history of databases, which took us from the dawn of computing to the invention of SQLite, which played a key role in making the Internet of Things a reality. In order to get some hands-on experience using SQLite, we built a couple of simple examples using the SQLite.jl package, just so we can learn the basic syntax of using SQLite. But I didn't actually cover any of the query commands, which of course is one of the primary aspects of a query language. So I'll be making another tutorial on SQLite, where I'll go into SQLite in more detail. Stay tuned for that episode next week. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julie tutorials, please be sure to subscribe and hit that bell. If you like what I do, then please consider joining and becoming a channel member. New tutorials are posted on Sundays/Mondays. Thanks for watching, and I'll see you in the next video.